Welcome to the Copperfield Electric Podcast. Okay, let's unpack this. Electric vehicles. They're moving really fast from being, futuristic things to just standard household appliances now. And the key really to making an EV work smoothly in your life, it's efficient charging right there at home. We're mostly talking about level 2 charging. That's the 240 volt setup, the one that makes plugging in actually worthwhile time-wise. But hang on, before you click buy on that charger, there's this really fundamental piece of your house we need to dive into, your home's main electrical panel. So our mission today, using the info from Copperfield Electric, is to explain exactly why getting a panel upgrade for EV charging, well, why it isn't just some nice-to-have luxury. Often it's actually critical, like a non-negotiable thing for safety and performance. We'll dig into the technical needs, the safety stuff, and the long-term pluses of this kind of investment, especially if you're listening in Southern California where, let's be honest, the grid gets a workout already.
And guiding us through this, well, we're leaning on the expertise provided by Copperfield Electric. They're family-owned, fully licensed, bonded, insured, the whole deal. A 24-hour electrician covering Orange County, places like Irvine, Anaheim, down to Newport Beach, Costa Mesa, Santa Ana, all those areas. They really provided the groundwork for this safety-first perspective we're taking.
And that safety-first angle is just so important because, look, it's exciting that everyone's getting EVs, right? But it forces homeowners to face this bottleneck that exists in a lot of older homes, the electrical system itself. People often think, oh, I've got power, so I must have enough power. And honestly, that can be a really dangerous assumption.
That's a great point. And when we talk charging, there's a big difference we need to make clear right away.
Yep.
Between the really slow level 1 chargers, those just plug into a normal 120-volt wall outlet.
Right. Standard outlet, very slow charge, often doesn't need any upgrade.
And then the much faster level 2 chargers. That's what most people want because, who wants to wait 30 hours? Level 2 brings that down to maybe, 4 to 8 hours?
Exactly. But that speed, it comes at a cost. Literally, a cost to your panel's capacity. Level 1 charger, it sips power. Maybe 12 amps, 16 amps max. You can pretty much plug it in anywhere. Level 2 charger, though, that's a different beast entirely. It needs its own dedicated 240-volt circuit. And usually it needs a 50-amp breaker just to handle the continuous draw, which is typically around 40 amps.
Okay, hold on. 40 amps continuously.
Yeah.
For maybe 8 hours straight.
Yeah.
Now, for someone like me who doesn't, think in amps and volts every day, that sounds like a lot. Can you put that into perspective? How does that compare to running, say, your central air conditioning or maybe the oven?
Yeah, that's where the really key insight is. And it's kind of fascinating when you break it down. Most of the big power users in your house think your clothes dryer, your oven, central AC, they pull a lot of amps, sure. But crucially, they cycle. They turn on, turn off. The dryer's high heat isn't constant. The oven hits a temp, then coasts. The AC compressor kicks on, then off. Their high demand is often, it's momentary. Or maybe intermittent is a better word.
Okay, so they spike, but they don't stay spiked.
Precisely. But an EV charger, that's totally different. When you plug your car in, especially if the battery's pretty low, it could pull that full 40 amps nonstop for the entire charge. We're talking 4, 6, maybe 8 hours without letting up. In fact, the National Electrical Code actually classifies EV charging as a continuous load. And systems have to be designed differently for that. They have to handle that long, intense heat buildup.
Wow. So it's not just about the peak power it draws. It's the duration, the sheer length of time it's drawing that much power. It's like asking your electrical system to run a marathon, not just a quick sprint.
That's a perfect analogy, exactly. And if you connect that to the bigger picture, think about homes built before, say, the 1990s. A lot of those, especially in some older parts of Orange County, probably have 100-amp panels. Now, a 100-amp panel might already be pretty close to its limit, just handling the AC, maybe an electric water heater, all the lights and normal appliances. Then you try to layer an extra 40 amps continuously on top of all that. That system just wasn't built for it. Fundamentally wasn't.
Okay, this is where reading the source material, it got really interesting for me. Because they're saying this stops being about charging speed and immediately becomes about safety, like fundamental safety.
Yeah.
What are the actual dangers if someone tries to, shoehorn a level 2 charger onto an old, undersized 100-amp panel?
Well, the number one risk, plain and simple, is fire, electrical fire. Look, if your panel's capacity is constantly being exceeded, your breakers might trip all the time. That's annoying, sure, but it means the breaker's doing its job, thankfully. But the more dangerous situation is if the breakers themselves are old or failing, or if the components inside the panel are degraded, then the wires themselves can just get incredibly hot. Continuous heavy load means heat. That heat breaks down the insulation on the wires, And eventually that can lead to a short, an arc, and potentially a fire, either right there in the panel or in the wall around it.
So that 100-amp system is basically running on borrowed time.
You could say that, yeah. Especially if you already have other big 240-volt appliances like central air or an electric dryer. Adding that constant EV load is like putting this huge, sustained drain on an already stressed system, you know? It builds pressure, and eventually something's got to give. Something could burst.
So the fix isn't just, oh, let's add another breaker. The sources are pretty clear. It's usually about replacing the whole main panel.
That's generally the recommendation, yes. The standard consensus solution is upgrading to a 200-amp panel. This upgrade basically gives you the necessary breathing room, the headroom. A 200-amp panel lets you safely put in that dedicated 50-amp circuit just for your EV charger. And you still have plenty of capacity left over, maybe 150 amps or so, to handle all your other regular household loads, your AC, your water heater, lights, everything else, without stressing the system.
Okay, but wait a second. What if someone only has one EV? And maybe they don't use their AC all that often. Could they, potentially get by with something less? Maybe some kind of smart panel or load manager.
That's a fair question. And yes, there are things like load management devices out there, gadgets that monitor your total usage and maybe temporarily pause the EV charging if, say, the AC kicks on. But we really have to think about the future here and the overall value and safety of the home. Most reputable electricians, like the folks at Copperfield Electric who provided this info, they usually advise going for the full 200-amp upgrade. Why? Because it just eliminates the risk entirely and provides long-term stability. Look, a 200-amp panel is pretty much the modern standard now, and for good reason. It makes sure that when you do have that really hot day and the AC is blasting and the car needs charging, your system can handle all of it without breaking a sweat. You minimize voltage drops, everything runs cooler, and critically, it's much, much safer. It basically moves your home from being just sort of electrically adequate to being electrically robust.
That makes sense, that idea of robustness. It connects right into the 4 big benefits that the source material really hammered home. Moving beyond just needing to charge that first EV. Let's tick them off. First, the obvious one. Handling increased electric demand. A 200-amp panel isn't just for the car. It validates the systems you already count on, right? Like here in Southern California, having reliable AC isn't a luxury, it's essential. This upgrade ensures that even when everything's running AC, washer, dryer, EV charging the house, stays safe and functions properly.
Absolutely. And that flows right into the second benefit, which honestly might be the most important one long term. Future-proofing your home. Electrification isn't stopping at cars, We're seeing huge pushes towards electric heat pump HVAC systems, those fancy induction stoves, people adding solar with battery backup like power walls.
Right, everything's going electric.
Yeah, pretty much. And all those things, they draw significant power. They need capacity. So if you upgrade your panel now for the EV, you're basically presetting your home for the next 10, 20 years of technology. You avoid having to do more expensive, disruptive electrical work down the road when you decide to add that heat pump or maybe even a second EV charger.
Okay, I like that. Turning a needed expense now into basically a preventative investment for the future. Smart. What about number 3? Improved safety and efficiency. We talked safety regarding fire risk, but does a bigger, better panel actually make charging more efficient somehow?
Well, it can't, indirectly. Think about it. When a panel is pushed right to its limit or even overloaded, you can get voltage drops under that heavy load. Now, it might be small, but that inefficiency means your devices, including that expensive level 2 charger, might have to work a little harder to pull the power they need. That can create extra heat, maybe even slightly longer charge times. A solid 200-amp system ensures smooth, stable power delivery, which means the charging process itself is likely to be smoother, maybe a bit quicker, and most importantly, it's running well within safe temperature limits. Less stress on everything.
Gotcha. And the final one, number 4, cost savings over time. This is looking at the bigger financial picture, right? The upgrade costs money up front, definitely. But what future costs are you potentially avoiding?
Oh, huge potential costs. First, you're avoiding the catastrophic cost of, an electrical fire and the resulting damage. That's the big one. But you're also avoiding the smaller nagging costs, like paying for emergency service calls when components fail because they're constantly overworked, replacing breakers that trip all the time, and even potentially replacing sensitive electronics computers, TVs, appliances that can get damaged by the unstable voltage you might see from a seriously overloaded system. So, that upfront investment in solid infrastructure can really maximize the lifespan of everything else plugged into it and save you money and headaches later.
Okay, let's shift gears a bit to the practical side, the logistics. Because for a lot of listeners, the number one question is going to be, okay, how much does this actually cost?
Yeah.
Based on the sources we looked at from Copperfield Electric, the typical range for a professional panel upgrade seems to be somewhere between, what, $1,500 and $3,000? That feels like a pretty wide range. What makes a job cost $1,500 versus one that hits $3,000 or maybe even more?
Yeah, it's rarely just one single thing. It's usually a mix of factors specific to your actual house. The lower end, maybe that $1,500 range, that might be a relatively straightforward swap, like replacing an old panel that's already conveniently located on an outside wall. Minimal fuss, maybe not much coordination needed with the utility company.
Okay, the simple scenario.
Right. Now, the price starts climbing towards the higher end, the $3,000 mark or more, when things get complicated. We're talking about situations where the panel needs to be moved. Maybe it's currently indoors in a closet and code now requires it outside. That involves a lot more work. Or maybe the main service entry cable, those really thick wires that come from the utility meter into your panel, maybe those aren't rated for 200 amps and need to be upgraded too.
Ah, so replacing the main feed into the house.
Exactly. That often involves trenching, permits, significant coordination with the power company. All of that adds labor time and material costs. And of course, labor rates themselves vary quite a bit across different parts of Southern California. So location plays a role too.
Right. So if you're listening and you know your panel is like buried in some tiny closet deep inside your house, you should probably mentally prepare for the higher end of that estimate.
Yeah, that's a safe bet. Complexity definitely adds cost. But look, regardless of where your specific job falls within that price range, it's really crucial to remember what you're paying for. This isn't just some handyman pulling wires. This is a licensed, bonded, and insured professional, like the electricians at Copperfield Electric. They're safety experts, upgrading the absolute heart of your home's electrical system. They know the codes, they pull the right permits, they make sure the work passes inspection. When you weigh that against the benefits and, lasting performance, proven safety, being ready for the future, that initial investment really does start to look worthwhile.
Yeah, that puts it in perspective. Okay, so wrapping this up, what's the big takeaway here? It seems like if you're serious about getting level 2 EV charging at home, upgrading your panel to 200 amps, it really shifts from being just an optional nice-to-have to being a critical safety measure. It's basically the foundation you need to make sure your home can safely, reliably handle the demands of this electric future we're heading into, especially that continuous high-power draw.
Absolutely. And that focus on quality, on doing it right, on transparency, that's really what drives providers like Copperfield Electric, who gave us this background. They're available 24/7 across Orange County. They aim for competitive pricing, but most importantly, they offer professional assessments. They can actually look at your specific home, calculate your load, and tell you exactly what you need, and they back it with a satisfaction guarantee.
It really underscores that electrification isn't just about buying the cool new car. It's also about making sure the infrastructure back home is ready for it.
Which actually brings up a really important final thought for you, the listener. Have you just been kind of cruising along with your existing panel, maybe not even knowing its capacity? Is it a 100-amp panel? Maybe your home was built before the 90s. Or perhaps you've added big appliances over the years, central AC, a pool pump, a hot tub. Do you actually know if your current electrical system has any breathing room left, any headroom at all? Even if you're not getting an EV right now, maybe it's time to find out if your system is already running close to the edge, running on borrowed capacity, so to speak. Just understanding your panel's capacity, that's really the essential first step in making sure your home is ready for today's demands and ready for whatever electrical needs come next.
That is a vital piece of knowledge for pretty much any homeowner these days. Really good point. Thanks for joining us for this deep dive.